We'll be shifting gears in this book to some 3D geometry. Most of the propositions in this book are supportive of the next two books. We'll start this introduction with a new set of 28 definitions to support the change to 3D. First, a solid has interestingly 3 dimensions, whose extremities are surfaces. Without defining a plane, Euclid defines what it means for a line and plane to be perpendicular to each other. Given a point on a plane, we can draw lots of lines that go through it on the plane. If a line is perpendicular to the plane at that point, it is perpendicular to all of these lines through that point. The intersection of two planes is a line, so if one plane is perpendicular to another plane, all lines in one plane, perpendicular to that intersection, are perpendicular to the other plane. If not perpendicular, how do we measure the angle of a line or a plane makes with one other plane? For a line, take one of its points outside the plane and drop a perpendicular to the plane, and connect that point to the start of the first line. We now have a triangle, and this angle is the angle between the plane and the line. For planes, they intersect at lines, so pick a point on that line, and draw perpendiculars in both planes. This gives us an obtuse and an acute angle to choose from. Euclid chooses to identify the acute angle as the angle between the planes. If planes intersect in the same angle, Euclid calls them similarly inclined. If planes don't intersect, they are parallel. If two different solids are made out of the same number of faces, which are similarly inclined, or with the same angles, they are called similar, and if these surfaces are also equal, the solids are equal. Angles and circles are connected. Take a point and draw a line, make a copy of that line and rotate it about the point. Now the lines make an angle, and that angle tells us how much along a circle that line has rotated. We'll call this type of angle planar angle. There's a similar concept for spheres called solid angles. If more than two non-planar lines intersect at a point, we can draw a sphere about that point. Then, these lines make up a set of planar angles which cut a section out of the sphere, so the size of a solid angle tells us how much of a sphere the angle contains. Euclid does not employ any units for this concept. This solid angle is called a pyramid. We identify it by this point, the tip, and its opposite surface. So we start from some planar shape, and then draw its sides to meet at a point. If instead we draw the sides parallel, we get a prism whose sides are parallelograms, and the top and bottom are equal shapes. Now, take a semicircle, fix its diameter, and rotate it about its diameter. This gives us a sphere. The diameter is called its axis, and it has the same center as the semicircle we started with. Any line through its center is a diameter. Now take a right triangle and fix one of its non-hypotenuse edges, and just like the sphere, rotate it around that leg. We get a cone. If the two legs are equal, we have a right cone. This is an acute cone, and this is an obtuse. The line we rotated about is its axis. The base of a cone is a circle. If instead we start with a rectangle, we'll get a cylinder. The fixed edge is its axis, and its top and bottom are circles. If a cylinder or cone's axis and bases are proportional, they are considered similar. Let's close this discussion with the Platonic solids. A Platonic solid is made by taking some number of regular polygons and making a solid out of them. A regular polygon is one where all sides are equal, and all internal angles are equal. If we take 4 three-gons, or equilateral triangles, we get a tetrahedron. If we take 6 four-gons, or squares, we get a cube. 8 3-gons gives us an octahedron. 23 gons gets us an isosahedron. Finally, 12 5-gons, or pentagons, gives us a dodecahedron. These make up the 5 Platonic solids. As we'll discover later in Euclid, these are the only Platonic solids. They're called Platonic solids because Plato gives a discussion of them in his Timaeus, where he postulates that the 4 elements, fire, water, earth, and air, are made out of these solids. So earth is made of cubes, because they are very stable. Fire is made of tetrahedrons because they are pointy, so fire burns because it is pointy. Water is like isosahedrons because it rolls like water, and air is the octahedron because why not? The 5th solid, dodecahedron, is what makes up the heavens because it has to go somewhere, and it's made of pentagons, not triangles. So if you could understand the Platonic solids, you can understand all of creation. This is perhaps why the Platonic solids are the grand finale of the Euclid elements.